So in 4.3, we're going to find out a constant rate does not necessarily mean that a relationship is proportional. We're going to look at a graph that has a proportional relationship, always has the line that goes through the origin. And we're also going to highlight and emphasize that the unit rate is represented by the letter K, or the constant in the equation y equals kx. Drawn over here, y equals kx. And if we take a look here at this equation, y equals 5x, this 5 is in that k position. K is our unit rate. What that's telling us is that 5 times whatever x is going to be, the y is going to be 5 times that amount. Down here, and then we have water and the time, okay? If x is 2, 5 times 2, that's going to be 10. If x is 3, 15. If x is 10, 5 times 10, x is 50. So now this one is kind of a little different. Well, time is in the x position, water is in the y. So what we have to do is we have to take this and change the equation around a little bit, and we're going to go 35 equals 5x. Okay, 5 is constant. We do not know what x is, and they give us 35, which is in the y position. That's why we're going to write that there. Okay. Two ways that you can look at this. You can say to yourself, 5 times what number gives me 35, and of course use your multiplication tables for that. Or what we're going to do is, if I get rid of my 5 on this side, and I do that by division, because the opposite of multiplication, which is what this is division, I do the same thing over here. Do the division over here, 5. 35 divided by 5, and that's going to equal 7. So x is going to equal 7. So then I would write 7 in here. Down here it says write the data in the tables as ordered pairs. Well, another name for ordered pairs is coordinate pairs. Ordered pairs are also going to be called coordinate pairs. Okay? So 1 and 5, and we always write the x first, followed by the y. So if you can't remember, think alphabet, x then y. 2 and 10, 3 and 15. We're going to put our 7 here in the x position because that's what we found, and 10 and 50. So they've given us a graph over here already set up where they have the time. Remember, time is the independent variable. So the independent variable goes in the x-axis. This is the y. Okay? So the independent variable always goes in the x-axis, and the dependent variable goes in the y-axis. Okay? You're going to have to figure out a scale on how to set that up, and you're going to do it based on your data. And to plot these points, what we call plot, or to go ahead and here they even say plot the ordered pairs, is I always start at the origin. Okay, so I always start at origin, and the origin is always, I'm going to just use this space here, the origin is always the 0 is 0, 0. 0x, 0y. Okay, so if you take a look at it, 0, 0, 0. So I'm going to start here. I'm going to go over 1 on the x because this is the x. X is first, y is second. So I'm going to start, I'm going to go over 1, and then I'm going to go up 5. Well, notice my scale goes up by 5s here, and this scale goes up by 1. And then I'm going to plot a point. Then I go over, my next one is 2 and 10, so 2 and 10. My next one is 3 and 15, so 3 and 15. My next one is 7 and 35, all right? So here's 7, and then I go up to 35 right there. Okay? And then my last one is 10 and 50. So 10 and 50. Now, I expect you to be close, but it is a graph, okay? And then the other thing I want you to learn to get in the habit is draw a line through the points. And this is the key right here. Does it go through the origin? If that line goes through the origin, you have a proportional relationship. If you do not go through the origin, then it is not a proportional relationship. And if you were to look on the table, you would be looking for these points right here. When x is 0, y would be 0. So you could look at a table, you could look at a graph to determine whether it's proportional or not. Now, the table and the graph are not always going to give that information to you. You can't just assume that. You got to figure it out. Okay. So then down here on G, I want you to figure out this part here. Okay. So you're going to use that equation, y equals 5x. Right. So you're going to take 23. You're going to put it in place here. So 5 times 23. So that's going to equal 115. And then what you're going to do is you're going to compare that and the 125. Okay? So what this is telling you that is if x is 23 and you put it into the equation, 23 times 5, does that equal 125? Well, when you do the math, no, it does not equal it because it's 115. So then if you continue the table to include 23 minutes, would the point, the ordered pairs, 23, 125 be on the graph? So the answer should be no, because 23 times 5 should have the ordered pair of 23, 115. Okay? Now use the pairs. For 23 minutes, you should be at 115 gallons used. Okay? So all I did was I just used the titles from the x at 23 minutes and then 115 gallons used. So here in example 1, there's just another example. Okay, here's time, here's total cost. So who controls who? Which one is the independent? Which one is the dependent? Does the hours control the cost, or does the cost control the hours? So they already set it up down here. They've kind of given you a hint. Okay, so time controls the cost. So time is going to be the x and cost is the y. Okay. They just turned in the ordered pairs. So here's 45 and 1. What's another name for this called? Unit rate. And then they go ahead and they plot them out, and that's what it looks like. I also should have mentioned that the line goes through the origin. It is proportional then. You have the your turn here. So they have total cost. They already give you this graph here, so that's y. They've already given you the total cost on the y-axis and the gains on the x-axis. So this is y, this is x. Remember your equation, k equals y over x. So you're going to do 11 over 1. You're going to do 16 over 2, 21 over 3, and 26 over 4. So this is already at 1, so that's your unit rate. 16 divided by 2 is 8 over 1. 21 over 3 is 7 over 1. 26 over 4. So you would go ahead and plot these here. You go over 1 and up 11, which would be about right here, and so forth. And then you would draw that line to see if it goes through the origin or not. If it does not go through the origin, it is not proportional. If it does go through the origin, then it is. So I've highlighted this paragraph here. Remember the y equals kx, okay? And it says the constant of proportionality k tells you how steep the graph of the line of the relationship is. The greater the absolute value of k, the steeper the line. Basically, they're just talking about that number. So if we had y equals 2x, and we compared that to, say, y equals 5x, this line, if we looked at a graph, and if we just plotted it out, this would be the 2x here, and then if we did the 5x, it would be up here. So this is a steeper slope, okay? And we're going to get into that in the next unit, actually. Example 2 goes back through with what we just talked about, so I'm not going to spend time on that. When we look at the your turn here after example 2, what does the point 460 represent? So remember, that's the x, that's the y, okay? So you simply look down here at your title. So this represents 4 hours, and the distance represents 60 miles, okay? So if you were to follow that, there's the 60, and follow that up like that, there's the 4, okay? So you would write something, it represents like how far the bicyclist went 60 miles in 4 hours, something like that. What is the constant of proportionality? Well, you have to, one, if you take a look, it looks like that it's all a straight line. It looks like it goes through the origin, okay? So you would take, you have 1 at, that kind of looks like 15, okay? So you create your own table. So there's 15 over 1. So I'm going to put my y on top, I'm going to put my x here. Okay, then my next one is 2, and let's see, that's 10, 20, so that's 30. So 30 and 2. Then I'm at, next point is 3, and looks like 45, because that's 50, that's 40, and it's halfway in between. So 45 and 3. Notice I'm creating my own table. I already got 60 over 4. And then looks like this last one is here is 6. So that's 80, so that's 90. So 90 over 6. And you go do the math, okay, so this is all 15 over 1, so that's a unit rate. So everything has to match up to that. So 30 over 2 is 15 over 1. Oops, 15 over 1. 45 over 3 is 15 over 1. So you got to make that comparison. 60 over 4 and 90 over 6 are also 15 over 1. So what is the constant of proportionality? It's 15. Then you take that and you substitute it into place here. Write an equation in the form of y equals kx. So then that y equals 15 over x. So you have your guided practice to do and your independence. If you have any questions, please let me know.